Hey everyone, it might not be freezing outside, but we're still going to talk about isotopes. Get it? Ice. All right, never mind. So when we talked about Dalton earlier on, Dalton thought that all elements had atoms and the atoms of a given element were absolutely identical. And that idea hung around for a while until our friend James Chadwick realized that we could actually have different number of neutrons and still have the same element because protons are what identifies the identity of an element. So let's discuss some of these isotopes. We had to kind of rearrange Dalton's statement to say that all atoms of a given element are the same and they have the same numbers of protons and electrons because they're neutral, right? Equal number of positive and negative things, but they may have different numbers of neutrons, those neutral particles. So what we call those are isotopes. Again, same number of protons, different numbers of neutrons, and that means that they have the same chemical properties because they have the same number of protons, same number of electrons, but they often have different masses, or they will have different masses because they have different numbers of those subatomic particles. So we give a letter to this. We give that letter A. Letter A is called the mass number, different than the atomic mass. So the mass number is actually not typically found on the periodic table. The mass number is actually equal to the number of protons plus the number of neutrons. And you can see that down here. This allows us to distinguish between different isotopes. We'll talk about that atomic mass that you see that has the decimal point on the periodic table in our next video. So there are a couple different ways we can write this. Number one, we can write a notation that has the type of element followed by an example of its mass number. So for instance, if we had carbon, carbon 14 is one type of carbon, and here's how we decipher it. Carbon, we know from the periodic table, has an atomic number of 6, so that means it has 6 protons. And we also know that on our mass number notation here, we have 14 total protons plus neutrons, which means if we have a total of 14 protons plus neutrons and we have 6 of these, that means we must have 8 neutrons. So the neutrons here would be equal to 8. So that's one way of writing that. Another way of writing this is to give a little bit more information. So you could also include the atomic number. And so in the same example, we had carbon. Carbon we know has an atomic number of 6. We also have 14 total protons plus neutrons. So not given here, but something you can figure out is the total of neutrons, which is 8, because 14 minus 6 is 8. So let's try this. Let's do this with a little bit of practice problems. I'm going to join you on your note guide. Let's see if we can write out both of those notations for each of the following instances. So let's do it for an atom with 21 protons, 24 neutrons, and 21 electrons. The first thing that might be helpful to do is to figure out what atom we are talking about here. So let's look to our periodic table, and remember the protons dictate the atom. Right, so if we have 21 on our periodic table, we have scandium. So that's Sc. Protons plus neutrons gives us A, that's that mass number. So if we add 21 plus 24 together, we get 45. So one way of writing that is Sc45. And that notation is done. All good. Another way of writing it, though, is to give a little bit more information. So we could write the Sc with that mass number of 45 on the upper left, and then the atomic number, which we said is 21, down here. Now you'll notice we haven't touched the electrons, and that's because we have equal numbers of protons and electrons, which means we have a neutral atom. And the place where we're going to distinguish whether we have a neutral or charged atom is up here. We're going to make it an ion, and because it's neutral, we are not going to write anything there because it has no charge. So we'll see if that stays the same throughout these examples. Let's try the atom that has 53 protons, 74 neutrons, and 53 electrons. Let's again find it on our periodic table. 53 is next to iodine. So we could write out iodine, followed by the mass number. The mass number is 53 plus 74. So if you do 53 plus 74, you are going to get 127. The other way of writing this, of course, is in our notation where we put iodine here. We put the 127 mass number up in the upper left, and we put the atomic number 53 down in the lower left. Now again, we have equal numbers of protons, we have equal numbers of electrons, And so if we have equal numbers of protons plus electrons, that means that we have a neutral atom, so we're not going to put a charge up here. We're just going to leave this blank. Let's try another. How about the atom with 17 protons, 18 neutrons, 18 electrons? If we do some math, or first let's figure out the identity of the atom. 17 is above chlorine. We can get its mass number by adding 17 plus 18 together. So that gives us 35. So we have chlorine 35. We know we can write that a different way by having Cl. We'll put the atomic number of 17 down here and the mass number of 35 up here. And now we have a situation with different protons and electrons. So we have one extra negative thing. We are going to put a -1 up there. You'll notice we've just filled in a charge, and the notation on the left here, this does not tell us if we have a charged particle. So clearly a little bit more information in the blue notation that you see on the right. Let's talk about how many protons, neutrons, and electrons are present in each of the following. And my copy is a little bit bad here, but yours is good. So you have, let me just write these in for us. On your paper, you should have these. We should have Fe with 56 as the mass number and 26 as the atomic number. We should have Al, which is aluminum with a +3 charge, 27 and 13. And then letter C is going to be selenium, Se, with a -2 charge. We've got 79 up here. We've got 34 down here, and we can just fix my copying like so. Sorry about that. Let's now jump in and see if we can identify the number of protons, neutrons, and electrons. So first off, given that we have this really nice notation, the protons are going to be easy, right? Protons are simply the atomic number. So we have 26 protons for sure. We also can do neutrons because 56 minus 26, mass number minus atomic number, gives us neutrons. So 56 minus 26 is 30. Be careful not to just write 56 neutrons. 56 is the total of protons plus neutrons. And we also need to do electrons. This is a neutral atom, so our positive charges and our negative charges must be equal. We have 26 positive, we must have 26 negative. Looking at aluminum with a +3 charge. Again, protons are easy, it's just the atomic number. We have 13 protons. To get neutrons, it's not 27, it's 27 minus 13, so that gives us 14 neutrons. And then we have 3 extra positive things. So if we have 3 extra positive things and you have 13 protons, that means you have 10 electrons to give you 3 extra positives. And finally, down here on selenium, we have 34 as our atomic number, so we have 34 protons. It's not 79 neutrons, it's 79 minus 34, so that's going to be 45 neutrons. You'll notice we have a -2 charge, that means we have 2 extra negative things. If we have 34 positive things, we must have 36 negative things.